Hey everyone, welcome back. This is part one of a two-part series on Python's numeric data types. In this video, we're covering the basics, what int, float, and complex are, how Python stores each one in memory, and the key properties you need to know before you start using them. Let's get into it. Starting with int, a whole number, no decimal point, can be positive, negative, or zero. Python ints have four key properties. First, no fixed size limit. A small number like 42 takes 28 bytes, but a 100-digit number takes 72 bytes. The size grows with the value. Let's understand this with example. When you write x equals 42, Python doesn't just store the number 42. It creates a full int object in memory with 4 fields. The first 3 fields make up the 24 bytes of overhead. First is object reference count, 8 bytes that track how many variables are pointing to this object. When that count hits 0, Python frees the memory automatically. Second is object type, 8 bytes storing a pointer to the int class. This is how Python knows the type of the object at runtime. Third is object size, 8 bytes that store how many 30-bit digit chunks the value uses. Then comes the actual value. For 42, that's just one chunk, 4 bytes. So the total is 24 bytes of overhead plus 4 bytes of value, giving you exactly 28 bytes. Now you might wonder, why does 10 to the power of 100 take 72 bytes exactly? Python stores large numbers in chunks of 30 bits each. A 100-digit number needs 333 bits to represent in binary. Divide 333 by 30 and round up. That gives 12 chunks. Each chunk is 4 bytes, so 12 times 4 is 48 bytes. Add the fixed 24-byte overhead, and you get exactly 72 bytes. Second, ints are exact. 7 is always exactly 7, no rounding ever. Third, ints are immutable. Writing x equals 100 doesn't modify an existing object. Python creates a brand new one in memory. And fourth, any whole number literal is automatically an int. 42 is int. 42.0 is float. Now float, a number with a decimal point. Python stores floats using the IEEE 754 double precision standard. Unlike int, a float always takes exactly 24 bytes, 8 bytes for the value itself, plus 16 bytes of Python object overhead. Those 64 bits split into 3 parts. 1 bit for the sign, 0 means positive, 1 means negative. 11 bits for the exponent, which controls the magnitude of the number. And 52 bits for the mantissa, which stores the actual significant digits. The most important property to remember, floats are approximate, not exact. Binaries simply cannot represent 0.1 or 0.2 precisely. Python reliably stores about 15 to 17 significant digits. You can write floats as plain decimals like 3.14, or in scientific notation, 1 times 10 to the power of 10 means 10 to the power of 10. Now complex numbers, a number with a real part and an imaginary part, written as a plus bj. Python uses j instead of I because in engineering, I already means electric current. So 3 plus 2j has a real part of 3 and an imaginary part of 2. You can picture it as a point on a 2D plane, 3 along the horizontal real axis and 2 up the imaginary axis. Complex numbers have 4 key properties. First, both parts are stored as floats internally, so 3 plus 2j stores real as 3.0 and imaginary as 2.0. A complex number always takes 32 bytes, 16 bytes of object overhead, plus 8 bytes each for the real and imaginary floats. It's immutable, just like int and float. And you cannot compare complex numbers with greater than or less than. That raises a type error because complex numbers have no single magnitude to order by. You can write them as literals like 3 plus 2j, or use the complex function and pass the real and imaginary parts as separate arguments. And that's part 1. You now know what each numeric type is, how Python stores it, and what its key properties are. In Part 2, we'll cover operations and methods for all three types, type conversion, and built-in functions. See you there. Thank you so much for watching this tutorial. I hope you found this lesson helpful and easy to understand. If you enjoyed this video, please hit the like button. It really helps the channel grow. Don't forget to subscribe to the channel for more beginner-friendly programming tutorials and helpful tips. Feel free to comment your questions or thoughts below. I love hearing from you, and I try to respond to every comment. And don't forget to hit the bell icon so you get notified whenever I upload new videos. See you in the next lesson.